Hi, I'm Jeff Clarkson, and I'm the founder and Chief Technical Officer of UTComp. UTComp is an engineering and inspection company for FRP composite assets. I'm also the creator of the UltraAnalytix non-destructive testing system, which is in use worldwide in a wide range of industrial sectors. UTComp is an engineering and inspection company specializing in FRP and other composite materials. We are revolutionizing the way that industries inspect and maintain fiber-reinforced polymer tanks, pipes, and other assets for superior reliability, safety, and return on investment. The problem with most reliability testing for FRP composite assets is that the traditional methods are unreliable, inconvenient, and risky. These methods include destructive testing, or highly subjective visual inspection, both of which require operations to be, shut down and may involve confined space entry. This is such a problem that it has hampered the widespread adoption of FRP despite its unequal durability and environmental benefits as an industrial material. Many assets are retired too soon. This is the problem that I set out to solve. I wanted to make testing FRP assets as simple and as reliable as testing steel assets. Here, an example in this slide itself, this storage tank had been in service for 10 or 15 years. The owners were actually pretty concerned about the damage that the highly corrosive contents was inflicting on the inner surface of the tank. The other problem is that entering the tank, doing a confined space entry, was highly hazardous. We were able to inspect this from outside the tank while it was in operation. If you could inspect this type of asset without shutting down and without risking human health and safety, would you do it? What if you had a way to detect flaws that can't be seen by the human eye while preserving the structural integrity? What if you knew that this tank did not have to be replaced, that it is good for many more years? How much time and money would you save? The UltraAnalytix system has many benefits. It's non-destructive. There's no need to sacrifice assets for inspection, and the structural integrity of the asset is preserved. It's non-intrusive. Inspectors do not require access to the inside of the equipment, thereby minimizing confined space entry. You can inspect the equipment while it's in operation. There's no need for production downtime, and you get detailed service life forecasting reports so you can make the best asset management decisions based on hard data. UTComp's inspectors and engineers are certified under ASNT TC1A, which is actually required by some regulators. And best of all, it's reliable. It delivers results based on a validated algorithm that has been thoroughly tested in the lab and in the field for more than a dozen years. With UltraAnalytix, you'll know if your asset has 3 weeks or 30 years of service life left. The symbols on the map show that UltraAnalytix is now in use on 6 continents, providing NDT confidence. Here's how it works. The UltraAnalytix system combines ultrasonic data collected in the field along with a systematic external assessment. And the field data is then transmitted to UTComp so that our engineers can evaluate the data and process it through our proprietary validated algorithm. The analysis actually detects subsurface structural changes in the composite assets well before they become visible. And the client then receives a report that reveals the condition of the asset and an estimate of its remaining service life so that the usage can be maximized. It's simple, efficient, and incredibly quick. Regular inspections of assets over time allow us to create a monitoring curve to determine the rate of change in your asset's structural integrity, and that allows us to even further fine-tune the lifetime projection. In addition to determining the overall status of the equipment, UTComp will also assess the condition extent of damage found in the corrosion barrier if this information is available. This information will provide asset owners with the opportunity to make decisions based on a combination of corrosion barrier condition and full thickness FRP condition. Interestingly enough, our corrosion barrier assessment process works better with non-intrusive inspections. It works better when we get the readings originating from the outer surface or the non-process side of the equipment going towards the process side. The UltraAnalytix system has been in use commercially since 2008. It's the only proven non-destructive testing solution. We have extensively validated it, including more than 500 comparisons between UltraAnalytix and destructive tests. Our database has more than 4,000 assets under inspection, with millions of data values accumulating over time, continually making the analysis ever more precise and intelligent. Here's an example of a quick case study for some tanks and vessels for one customer only. This customer is a chemical and food processing giant. Their gross earnings are over $3 billion annually. They are global in extent. The equipment that we're looking at here on this chart comprises more than 200 tanks over a 3-year period. The age range is new to 35 years old. And what we're showing is the age of the asset inspected and the remaining service life projected for each one of those assets. We actually, when we got to 30 years of remaining service life, we didn't project beyond that. This company had planned replacement every 15 years for most of their storage tanks and process tanks. And for critical service or hydrochloric acid, they planned replacement at 7 years. That means that their tanks were expected to live along this red line, where if they were 15 years old, they had 0 years left. And if they were 0 years old, they had 15 years left. Well, in fact, you can see that everything up here above the line is outperforming that process. Everything below the line is underperforming. The key is to find out how to get these underperforming tanks into the outperforming side. The results of this work with this customer had us recommend replacement of 7 tanks, 7 out of more than 200. And the cost saving to the customer based on their age replacement process was somewhere on the order of $33 million only for the purchase of the tanks. That doesn't include the work to install the tank, perhaps modify some installation methods, or even the mechanic work to reconnect, to remove the tank and then reconnect the tank. So the savings were significantly greater than $33 million. Well, how much did it cost for this inspection? Well, it cost less than 1% of that money saved. Another case. This is piping in a phosphate plant near Aqaba, Jordan. More than 10 kilometers or 6 miles of piping was inspected of various sizes from say 50 millimeters diameter up to, I think, 400 millimeters diameter. The customer needed to know if the piping could be restarted safely. In fact, suppliers of piping equipment just said, why don't you just replace the pipe, which would have cost more than $10 million. For a fraction of that cost, significantly less than 10%, actually probably about 2% of that cost, we did a full evaluation and recommended restart with no replacement and only some minor repairs. Another example is a scrubber in a chemical recovery process in a large facility, a titanium dioxide facility in Canada. This scrubber is 23 years old. It's used in emissions control. The customer actually wanted to have ongoing reliability. At 10 years old, the equipment manufacturer actually said we should replace this. We looked at it, we assessed it, and since 2011, we've been able to cement in that it's got a projected service life of more than 20 years and minimal repair, no replacement. The cost savings of this particular set of actions was at least $3 million. What was the cost? What's the return on investment for that? We're looking at somewhere on the order of only a few percent of the replacement cost to be able to give that certainty to the customer. This is an example where a composite material was placed around a steel pipe that was too thin for continued safe operation. It had been corroded from the inside for an oil and gas customer. This customer itself has a global operation, and they use this type of composite overwrap in order to strengthen steel assets that may need some additional strengthening or reinforcement for at least a short-term operation before they can be replaced. Well, they wanted to know if this overwrap was capable of continuing in operation. So we did a survey, and in fact, you can see from the chart that we show, what we're showing is color code based on the detected thickness of the material. What we did find is that there was virtually no polymer damage at this point. The reason there was no polymer damage is because the polymer hadn't been exposed to any kind of a stretch or strain from stress. So as long as it hadn't been exposed to any of it, we weren't concerned at all. We actually recommended that they continue the use of this. It's got probably 30 or more years of predicted life remaining. The short-term cost saving to the customer was estimated to be about $20 million. We're pretty sure that the return on investment was very favorable. It cost well less than 5% of the cost savings to do this full assessment. Applications for new equipment or before you buy processes and process plants. You could use this process before purchasing a new plant to get a survey of the FRP in the plant to know the condition of the equipment. You could actually use UltraAnalytix to provide you with acceptance criteria for replacement equipment. You should also know when to service your equipment. So we track equipment as it ages. We use it to identify repair and replacement needs. We can baseline any repairs, and therefore we know where we're starting from. And as you repair on top of existing composite material, it actually becomes a little more complicated to solve. So it's useful to baseline that. And we can use it as a plan or part of the plan for capital replacements. UTComp can help you with all of your composite engineering needs. And where do we work? The industries that we serve range across the entire span or spectrum. Chemical treatment, mining and mineral processing, pulp and paper, water and wastewater, oil and gas, wind turbines. We've actually done some work in some structural elements for process plants that are highly corrosive. There have been more than 7,000 asset inspections completed to date. Work has been done on all continents except Antarctica. At least 193 customers have been served, and there are people trained around the world to be able to do this inspection and complete the required work in the field. If you have any questions, contact me or Joanne. Here's our contact information. We'd like very much to be able to help you determine whether or not UltraAnalytix is for you in your facility. Thanks.